Good evening. Welcome to the Plympton Public Safety Building Committee meeting. This meeting is being recorded for cable and YouTube presentation by Area 58 Community Access Media. This recording is not to be considered an official public record. Hi. So we're here. Zell and Jeff are not here yet. They are actually bringing us, I believe, enlarged copies of these things.
Oh, good.
11 by 17.
Oh, good. Okay,
He
good.
kind of asked, do you want those? I mean, we don't really need them. It's like, yeah, I think we, yeah, at least a couple. So he is bringing 10. So we don't have minutes yet because we have a busy new father, and we're okay with that. Basically, we need to wait for them unless, Jeff, you want to start us? I mean, Rob, I'm sorry. Do you want to start us along?
I don't have too much, other than we're currently working on getting the geotech analysis going out here, so we should see some activity within the next couple of weeks. It's not going to impact or slow down the design of the building in any way. It's going to take a day for them to come out here and do 4 to 5 borings, or however many they can do within that 8-hour span. And early conversations with a preferred driller who we've done a lot of work with indicate that the cost is going to be somewhere between $5,500 to $6,500 for them to come out here, including the analysis.
And is that what you basically budgeted?
Yeah. So, and usually the structural engineer on the architect's end will dictate where he wants to see the borings done. And on a building like this, on a site like this, generally it's each corner of the building and, you know, one in the middle if they've got time to do it. So they can see what the conditions are, obviously around the footings and, you know, under the slab. And, you know, but if the structural engineer says, you know what, give me 2, and let's do a couple more out, you know, we can do one in the, you know, if there's a drainage field or septic, you know, we can do a couple extra more. But we usually try and cram in as many as we can in one day, because that's what we have to pay for, is a lump sum 1-day rate. So,
Okay.
so we should have an update the next time.
Who are you going with?
A engineer goes by the name Charles Gross. I forget what
Gross.
town he's out of, but he's local. He's a local guy. We've done a number of projects with him. I think it's just Charles Gross. I don't think he has a different name for his company. But other than that, yeah, just, I guess we'll wait, see have Jeff walk us through the plans and the HVAC details.
Okay. Do you have a cell phone number for them or anything to see how far out they are?
Time's up.
No Bob tonight?
Is he
Still on the board?
On the boat.
Alrighty. So are we right now being driven by context, or do you have any idea of when we would need our next meeting?
I would ask that question for Jeff, yeah. See what he's thinking.
All right. Yeah.
I think based on our previous conversations, it's probably going to be another 3 to 4 weeks. Which-
So anybody want to sing and dance? Recitations?
Well, I just got a text from one, I don't know which, it says, Rob, we're almost there. It must be from either one of them. I don't know which one it is.
Okay. Sorry for the quiet, we'll just have a moment of peace.
Remember the hazmat?
Oh, you're bringing back silence at the
Remember
beginning of the
hazmat
meeting.
meeting?
Yes.
Lots of people that showed up for hazmat?
Oh, yeah, no, it went very well, yeah. Out straight from
I knew she
9
would.
o'clock until just before 12.
Yeah.
Yeah.
Get it all off the town's property, off the town land.
Yeah,
Not going to leach in somewhere.
Do it again
No.
next year?
I hope so. Yeah, it was very successful.
How much did it cost the town?
Well, they budgeted $5,000, and it cost us $49.80.
It's under budget, what can I say?
$20 for pizza.
But the amazing thing about it was that at about 5 minutes of 12, there was no one else waiting in line, and we had spent $49.80. I mean, it was scheduled from 9 to 12. It just so happened that everybody was taken care of, and we were under budget, so.
Great.
And tomorrow.
I think I told you I was surprised they didn't have more stuff. When I went through it, it was like, oh, no, that's latex, no, that's latex.
Yeah,
It's just,
there was a lot of latex, and the oil, like the waste oil, I turned away because we will be putting in tomorrow, the waste oil tank will be delivered. So we can take that from,
Only got that like 2 minutes ago.
This is Jeff, this is from Context.
Yeah, contact.
This is
P3.
Rob from P3.
hi.
Okay, so we already started and hit a lull.
Great, well, I'm glad we can take over. So there's a couple of things we need to talk about tonight, but it's probably a good thing to jump right into our guests who've been waiting, I imagine, over there in the corner, from Garcia Gillespie de Souza, to talk about the HVAC systems that are options, and hopefully with discussion may be able to land on a decision tonight, would be helpful. And also Chris Garcia talking about the plumbing and particularly septic aspects of the project. Let's start with HVAC, if you wouldn't mind.
So what's being passed out there is the life cycle analysis, and I've got some other material as well that kind of backs it up and is less boring to go through. So I think this will be the main point of the presentation, the top one.
Oh, also, these are two.
Yeah, they're
They're two
There's
each.
two.
Okay. Another set down.
Same with the phone.
So with the gray cover, the HVAC system engineering economic analysis, this is an overview of the other document which was passed around earlier, which is the actual life cycle report. So the goal of a life cycle analysis is to study a minimum of 3 different HVAC options in terms of first cost, operating costs, and maintenance costs over a select number of years, in this case 30 years of operation, to make our recommendation forward for which has the lowest overall life cycle cost of ownership, factoring in those. So essentially what we've looked at were your traditional code baseline system, which would be a split VAV furnace unit, air handling unit, and we could put the pros and cons associated with that.
So that's your typical furnace with the burner inside the air handler cabinet? Is that-
Correct. In this case, too, it could be with a boiler, but a gas-fired unit. So this is really just to determine your code baseline. The cons would be you've got multiple units within there. It's lower energy efficiency typically, but we want to establish a code baseline. Then we look at option 1, which is very similar, but improving that with higher efficiency furnaces. So the gas-fired furnace would be approximately 90% efficient. We'd have higher efficiency on the condensing sections for the air conditioning, and then we add energy recovery ventilation to that. So any exhaust air from restrooms, locker rooms, general exhaust are captured, run through what's called an energy recovery unit, and then that preheats or pre-cools the incoming code-required ventilation air, and then is ducted to the furnace distribution system. Has similar cons, higher noise levels because we've got fans, reduced temperature control still because not each individual space has its own thermostat. A group of rooms, we essentially zoned it out, so I think there's about approximately 5 of these units to fit all the different program requirements. So it'd still be a good level, but a con against some of the other systems that we're looking at. Maintenance of equipment is in an occupied area. That's more so if you had to build out closets. If we did these in attic or dedicated mechanical spaces, that's not, we can overcome that issue. A little higher energy consumption versus some of the other system. Overall, the ductwork costs are going to be higher than another system I'll be talking about because it's an all-air system. We're doing heating, air conditioning, ventilation through ductwork, whereas we're not doing it through either hot, chill water or refrigeration piping units. Option 2 essentially is the same system, but instead of a high-efficiency gas-fired furnace, we put in a hot water heating coil and provide that from heating from a high-efficiency boiler. Oftentimes, these are called, known as hydro air units. Higher energy efficiencies because of the hot water boiler is centralized and then providing the hot water heating to multiple air handling units. So you've got diversity working for you, economy of scale. You've got one boiler providing heating to multiple units. But the zone control would be very similar to the other option. We'd have approximately 5 air handling units throughout the space. So the primary gain here, we would still use energy recovery. The primary gain is from just using the hot water coil. The other thing too, with hot water heating, air is typically not as dry in the winter season. Typically the gas-fired heating process tends to dry out the air more than a hydro air system. So that's another benefit of this system. And finally, the last option studied was called a VRF, or a variable refrigerant flow system. With this system, there would be multiple units. There's each room would essentially become its own zone and do its own heating and cooling. So you've got much more controllability with the space, results in higher energy efficiency, but it does present itself with some more complex controls and a little more maintenance within the space, because instead of having 5 units, we'd have on the order, I don't know the exact number, but in the order of 20 to 30, because each of these rooms has at least one. Some rooms would have to have 2. They're flexible. They could be either the ductless type or ceiling cassette type, or even a fan coil type. And then all these units would be connected with refrigeration piping to outdoor condensing units. It gets its energy efficiency in a couple different means. Essentially, diversity is working for you in some cases. One zone might be in heating, the other would be in cooling. So before it sends the refrigerant to the condensing unit, the space that needs heating would transfer to the space that needs cooling and vice versa, and before it sends it out to the condensing unit. Also, it reduces, as conversely, it's not an all-air system. So we're not using ductwork to provide heating and air conditioning and ventilation. We're just using ductwork to provide ventilation air. So that allows the ductwork size to be smaller and saves on some fan energy usage. And on the next page, you can kind of see this energy recovery unit that would be part of the system. This would be of the options 1, 2, or 3, whereas the baseline does not have the energy recovery. The next page is just showing supplemental systems on the HVAC plant. It would really just be the high-efficiency boiler plant that would be pertinent to if we'd go with the hydro air units or with the VRF. With the VRF, we would be doing the majority of building heating through the VRF system, but there would be a recommendation to have a much smaller boiler plant doing some spaces such as sally port heating, entryway heating, corridor heating, restroom heating, really heating only spaces that you don't want to air condition and use the VRF equipment. That's what the boiler would be proposed for under that option. Just to describe the next page, just describes a flow chart of the process, how we arrived at the life cycle analysis. We use a program called eQuest, and from context plans, we import that into the computer program with all the different spaces, use local weather data, factor in the building occupancy and usage, system operating characteristics of and efficiencies of the different options, and the local utility rates, and that eQuest number will provide the operating costs of all system options. We then have to also weigh that against the installation costs, which we derive from in-house estimates based upon recent project cost data, and likewise from maintenance cost data. We use recent project costs to maintain all this different equipment. And we crunch the numbers using the program, DOE, Department of Energy program, BLC5, which then factors in escalation of fuel costs and helps us to come to our conclusion of lowest overall life cycle. So that's what I just described, is just put in bullet points on the next page. So a summary of the results. This would be the same results that could be found in the life cycle analysis. It shows that all of these systems in general would be, with the exception of the baseline, would be considered, and even that so with energy codes have become very strict as it is. So even a baseline code system is very good compared to what it was a few years ago. So they're all very good and energy efficient systems. It's just, each one tends to get a little bit more efficient, and in order to get that efficiency, you're paying some more first cost. So what we found is that the VRF system has the overall lowest cost of ownership and highest savings of $75,000 over the 30-year period, but that has a 12-year payback period versus the code baseline. Likewise, the hydro air would have a 15-year payback versus the code baseline, and just going with high efficiency gas furnaces would have an 18-year payback. We've used both systems, successfully on similar type projects. The VRF and the hydro air and gas-fired furnaces. I think in addition to this, we should just discuss some pros and cons, and we can certainly answer any questions. Just the other backup material, as I mentioned, the life cycle cost, and this other document is just some of the equipment you would see for the different systems. So, you know, some of the pros and cons, the VRF has become more and more popular, more and more energy efficient, and one of the drawbacks to the system only up till a few years ago was at low ambient or low outdoor air conditions, it could not operate to, you know, 0 degrees. Now it can. They always said, you know, up to 7 degrees it was rated for to provide heating. They've essentially addressed that information. The big pro of it is that you've got that individual temperature control for each space. Kind of a drawback of that is that you've got to maintain additional equipment within those areas.
So if that's the case, how come that has the lowest annual maintenance cost? When you look at the analysis.
Because it's done at, overall, they don't need to be maintained yearly. Like, there's really not something to be done unless it goes wrong with them, whereas, because they've got a very small fan motor, essentially a microprocessor controller, so on an annual basis, they need very little versus a larger air handling unit or furnace that, you know, has a traditional fan motor and such.
Burners too.
Yeah, and burners that need to be cleaned out, breaching that needs to be cleaned out. So it's our best estimate on it, but I would just say, you know, over a 30-year lifespan, you know, I would expect, you know, one unit could go, and essentially they become, to some degree, you know, throwaway technology, whereas if you've got to repair a computer board, you're probably going to spend $1,500 to have a tech come in, replace the chip and board, whereas it might cost $2,500 for a whole new unit itself. And that could be done by not a tech, but a local contractor. Again, they're, you know, very similar overall lifespans of approximately 15 to 20 years for any of these pieces of technology.
How are those systems, since they're generally located within the space? How quiet are they? Because I don't know what this thing is, but it's looking back and giving way.
Yeah, they're relatively, it's very quiet.
I mean, I guess, how are they quiet compared to a system that is located in a central space?
Probably similar, because you still have the ductwork noise and ductwork routing, and you're moving more air, whereas that was within the space, and they've got very quiet motors, brushless motors.
Okay.
Do they have a zone rating on those, or?
Yes.
Do you have approximate?
I don't know if they're in the cuts, but I could just say that we've never had a
Yeah, no, I haven't.
never had a sound concern from
I haven't
a
either.
VRF ductless unit. I've had plenty of fan coils and even overhead ducted VAVs, just sometimes how it gets installed, what's available for fit. You've got a bad elbow here and there, and that could cause noise.
So on the options for 2 and 3 with the boiler plant, would you also be taking a loop off of that for the domestic hot water supply? Or would that be its own separate?
That would be its own separate system. And why we typically do that is, so in summertime, we're not running a larger heating boiler for domestic hot water heating needs. You know, typically we've been able to maintain, like, you know, NC 35 to 40 within spaces with the ductless cooling units.
Yeah, this says about 29 decibels on those ceiling cassettes, which is pretty darn quiet.
Would some of these units have the opportunity to be in the trusses, or are they, regardless, are we aiming for this utility room? That boiler room?
I think we could mount even the air handlers up in the truss system.
Yeah, it's,
Okay.
there'd have to be, again, this life cycle does not factor in maybe some other architectural-related costs. If you now start putting units there and have to access them,
If we bury them up in the attic, it's gonna be a lot more expensive to
Then you've got
replace them in
planks.
15 to 20 years.
Yeah.
Than
Yeah.
it would be if you're just dealing with a VRF system.
which minimal ventilation unit, maybe
We might
one
be
or two
able
of
to
them.
hide the ERV units
Right,
within the occupied space in some
A
other
closet
areas,
or
closets or
mechanical
something, rather than
closet.
sticking them up in the attic.
but there'd be
And-
fewer of them, so.
And the only things that those need occasionally is the filter. Or the
Filter
cassette
changes.
needs to be
Yeah, the
replaced.
cassettes, depending on, the ERVs are about 10 years, I think.
And the ERV, the key to them is replacing filters, so you don't use the cassette as a filter.
Are you taking into consideration in option 3 the ductwork that will be needed for the ERV since everything else is ductless, or is that?
Yes, that's in the estimate, yep. And the fan energy for that portion of it.
So the goal, as challenging and daunting as it may seem, is to pick a system, given the information that you've received, and allow the engineer to start designing one of these various systems, because there is quite a bit of difference in how they have to proceed in their design based upon whichever one you choose. The obvious factors here are first cost, which is a pretty important thing to consider. But then obviously what it's going to be to live in the building and actually have to deal with the maintenance versus the operating costs, include the operating costs over time. So there's some sort of quality of life questions and issues to wrestle with relative to the first cost, and there's about a $60,000 spread between the lowest and the highest. And with the budget that we have for the project, $60,000 is a lot of money. It's not gonna, if you decide that you want to do the VRF, we're gonna make it work. But,
And there might even be some V that could be done
right.
on that system as well.
But it certainly makes it more challenging for us to make the budget work than if we did, even if we did the option 1, that's about a $25,000, $30,000 difference. It's still a significant difference with the budget that we have, because we're at about $2 million construction dollars, right? Yeah.
How do these numbers fit into what we've estimated for the HVAC component?
Because we haven't done an actual full-fledged cost estimate, we don't have to compare it to at this point. It's cost per square foot versus a detailed takeoff.
But we have been talking about an economic design from day one, and $60,000 spread in the grand scheme of things isn't a lot, but in this project, like you said, it could mean the difference between taking a good chunk out of one of our alternates. I talked to Dan about it briefly today, and, his gut was to recommend the baseline system, just because it's familiar, and, we really want to create a set of documents that when bidders open these things up on bid day, they just see a system that's, oh, this is a piece of cake, it will generate a good bid number, but in the VRF, he didn't give me the details, but has heard some feedback that the VRF numbers or the life cycle costs don't quite always reach the target numbers that they've been told early on.
But it's a life cycle, so just make sure I understand the math right here. You have a $75,000 life cycle savings cost compared to the baseline, but it costs $60,000 more.
So the net savings is
I mean, is that the right way to look at it?
Yeah, it's a 15,000.
So we're saving $15,000?
Over 30 years.
over 30 years.
Yeah.
But we're saving $15,000 over 30 years.
No, it's over 30 years, and you'd be saving 75,000 versus
But-
your baseline system.
But I'm paying-
There's these annual savings, but they're escalated.
But the
Yeah,
system
But I'm
is-
paying 60 more for it, or am I not
Upfront.
looking at that right?
You're paying, yeah, compared to the baseline, you're paying 60,000 more.
But it's
In addition
$75,000
to the
cheaper to run.
$75,000 cheaper,
Then, over the lifespan,
which includes first costs. So I think your 75 is an actual inclusive of the first cost difference,
Is
right?
it? That's what I'm trying to understand.
So if you compare first cost to first costs plus all the operating costs, you still end up with a $75,000 savings.
yes, because it's dollar per square foot annually, you're going to spend about $3.88 for the baseline versus $3.13 a square foot for that. And that happens over 30 years, and the fuel costs get escalated. So over the 30 years, you would save 75,000 over the 30 years.
Inclusive of the 60,000 that you
Inclusive.
spent upfront to put the system in. So
Right.
So you're really talking about a number of 115,000.
Cheaper to operate.
You know, the total savings is 115,000, but
But I
then
gotta pay the 60 to
then you
get
gotta
it.
pay the 60 up front.
Right.
So I
you're
net,
only- you're
I
only
net
getting
out,
70.
even paying the more money, I net out 75.
So you net out, the 75 is the net.
All right.
And earlier, you said that some of the VRF equipment has a life cycle of somewhere in the 15 to 20-year range.
But that could be said for these air handling
Yep.
units as well.
So does this 30-year projection take into account?
Doesn't, it's not
Doesn't
it does not
Okay.
include capital replacement for any option because we look at them like they're pretty much the
They
same.
should last, okay.
But it is a good point that was raised about the base system in option one and option two to some degree. You know, those, if you put those air handling plants up in the attic, there's going to be a cost that's not included here,
For access.
Get up there.
It's usually platforms.
and replace them when the work has to happen.
Yeah, but if I'm not mistaken, and I don't have the plans here, but don't we have a mechanical room
We have a boiler room, yeah.
that we
Can't
had?
fit all this
Can't fit
HVAC
all-
equipment. We can put the boiler in
The
it,
boiler and pumps could go in it,
yeah. And
maybe one unit.
yeah, maybe we can stick an ERV in, or, you know, there might be some portion of the whole total air handling equipment that might be able to fit in there, but if we go with something that's sort of, I want to say machinery intensive for air handling equipment, like the first few options, that's going to have to go in the attic. We don't have any other spots for that.
So you're saying the baseline wouldn't?
Baseline would have to go in the attic,
Attic.
yeah.
So
With
one
ductwork.
option, so the baseline 1 and 2 both have those issues.
And
Yes.
3.
Three is, we can deal with this. Three, because of the ventilation side of things, there's still going to be some ductwork. So we're trying to figure out ways
Flu- You don't have the flu problem.
to put the ERVs and things like that in more accessible places.
Right.
You will still have an air handler,
But with,
probably
But-
be up there.
I mean, but for certain of this stuff, don't you always? I mean, you put like an air, like a heat recovery system typically isn't sitting in a room. It's typically sitting in, I mean, some of this stuff, that's where it always goes.
Yeah, right. So typically you'd have ceiling space that this would go into, and you pop the ceiling tiles out like this, you know, and you'd have access to that equipment. And for things like air handlers, you want them in a separate room or on the roof
Right.
somewhere. But if you're dealing with an attic situation, and we're, in this particular attic, we don't have a set of stairs going up to it.
Right.
We're gonna have a hatch and an access way, so you'll be able to get up there, but it's not gonna be convenient, especially when, in 15, 20 years, when you actually have to replace the units. And I think that's more, maintenance is definitely a consideration, but the replacement is more of a concern in terms of the cost, because it's just gonna be harder for a HVAC company to come in and do the work. Let me tell you, they definitely have experience putting things in attics, and getting to it, so it can be done. It's just less easy than if it was more accessible on the roof. So it's simply just a consideration. If that's the option we want to go with, it's just something to keep in mind. Long-term, you will have to deal with that at some point.
Maintenance-wise, which system is the most inexpensive?
The VRF.
VRF.
The
At that
VRF.
point, you're
These
basically
pictures.
just changing the filters in the individual units and maintaining the probably 3 or 4 outside condensers.
Yeah, how we came up with, I think we include,
We don't,
this is our best estimate on page 23 of the life cycle analysis.
I think there's two ways to look at it. One is the costs associated with it, so that which one's cheaper than the others on average. The other thing to think about is the local economy. And, you know, the folks that you have available to you to actually do the maintenance and the service, and what companies would you reach out to work on these units to make sure that you can get the expertise that's familiar with and can easily work on it. I think that's Dan's point that you were mentioning, that, you know, in Dan's mind, the base system is kind of the most familiar, the easiest, everybody knows what it is, and they know how to deal with it. However, I think our point of view would be the VRFs have been out for quite a long time now. There's plenty of companies that can deal with refrigeration that's part of it. It's getting more and more popular type of thing. People are now doing it all the time in houses. So I doubt that there's going to be an HVAC company that you would consider hiring that wouldn't be able to deal with any of these systems.
Well, I'm thinking the other component is just day-to-day. I mean, and maybe you've already talked to the chief about this, but is this the building where we need individual control in every room? And correct me if I'm wrong, but are these usage estimates based on, they're probably based on some level of discipline, right? So, I mean, there's got to be a baseline for, you know, if every room is monitored, you know, if someone leaves the room cooling all night.
Well, the good thing about this
You know,
building
it's like,
is
how
there's
is it-
hardly anybody in it.
Well, true. I'm thinking, how is it
I mean,
regulated?
The training room's gonna have people in it, and then there's a few offices that'll have people in there on a daily basis, and maybe the detention on occasion. So I think if you're talking about, you know, set points and how do you control the system, there's not gonna be many people that complain if their office is too warm or too cold, and if they are complaining about it, it's gonna be, you know, 1 or 2 or 3 people that have to negotiate a zone. Whereas the VRF, with the individual controls, it gives you a high degree of control, but yet there isn't that many people that need to take advantage of that high degree of controllability. You know, one of the things we did want to talk about is the control system itself, because you don't necessarily have the budget to put on a full building management system here, nor do we have the expertise, I think, to
Yeah.
deal with a computerized
Yeah,
system.
so each of these would have their own standalone digital control system. You'd have
Programmable.
one for the VRF. It's got a master control, then each one has its own sensor. The sensors could actually, like I said, there's value engineering capable of all these systems. One of the we've often done with VRF is go wireless thermostats. And they're wireless and they just get mounted against the wall, and they have their own little sleeve, so you can't just take it out. You could secure it to the wall, but you're not having any wiring between that unit and between the thermostat and the unit itself. You know, the boiler would have its own little, you know, controller and pump relay system, but everything, these numbers are based upon pretty much standalone basic control systems.
And what does a VRF evaporator go for, roughly? So if you have, so you don't have as much regular maintenance of them, but they're gonna go.
We're carrying $3,000 per unit for 15 of them for the building, installed.
Is that the cost of the
That's the installed cost.
3,000 per unit?
Yeah. Probably about on the order of 2,000 to install it.
Yeah, I'm just thinking about that piece, because, I mean, if it breaks in such a way that, you know, you might as well just put a new unit in, and that's a budgeting question to make sure you have money in case a unit fails, versus a part in a more standard boiler, you replace the one part, and that's more within, you know, you're not going to do it regularly, but if you don't have the money there in the budget, so it's just something to think about if we go with the option, but it is also 60 grand out of a not very big budget.
Yeah. Do these gross capital investment costs take into account that the systems that are options 2 and 3 don't have nearly as much gas piping throughout the building. Is that savings reflected in these
No,
numbers?
it does not include the, well, let me see. Yeah, those are in the dollar per CFM for the gas. And, you know, what we factored in is pretty much if you're gonna be
Maintenance of the fire
within an attic
station. Is that in
space,
the
that's how
fire
we plan
budget?
the layout.
Or is that in the
You have the
overall
5
town
units
budget?
up there. Could use a,
Fine.
ductwork cost
So it
with
would be the same with the police,
based
it would be
on,
included in the
you've got
police.
one common maybe louver, you could duct the outdoor air to the ERVs and then to the units themselves, and then have on the opposite end maybe another exhaust louver. So they really just don't include the architectural impact costs.
So if, from one perspective to look at it is, if a piece fails, let's say the condenser outside for the VRF fails, that system is down.
Correct.
Whereas if only 1 or 2 of the furnaces failed, we still have some heat in the building.
Right. You would lose one zone.
Do you have any industry or past experience with replacement timelines on some of those parts?
Well, you'd still be running the ERVs, so you'd have a minimal amount.
And we still have a supplemental boiler plant, so.
If you're talking
we
about
wanna-
heating,
I'm just thinking if, you know, in February, a condenser decide, you know, let's say a piece of ice decides to fall in the condenser, or something happens to it, and it goes down, we
Yeah.
have no heat
Yep.
in the police station.
well, that's what I'm saying. I think you'll still have some heat, so it won't be like 40 degrees in the police station. It just won't be comfortable.
Well, no, it won't be, yeah, it'll still maintain its heat.
Yeah.
At that point, they should actually shut down the ERVs, so it doesn't bring in fresh
This
air
is-
and then temper out.
Yeah, this is gonna be 15 tons, so it's actually gonna be 2 modules,
Okay.
so it'll be 2 7.5s.
I don't know what the time frame is if you lead
Um,
time for those types of things.
couple of weeks.
That's my question, yeah. Because on the residential ones,
Same thing with the boiler, it'd be, you
yeah,
know.
these are.
Nowadays, no one stocks,
Not
or
this.
very rarely is there shelf stocking of HVAC equipment now.
It's all drop ship.
Yeah.
So what's the efficiency on the baseline system in the boilers?
80%.
80?
80.
Still make 80%?
Yeah, they do.
Yes.
It's because
Pretty
the,
awful, actually.
all the high
And
efficiency
like,
stuff
I
are
think
condensing.
13 or 14
So a lot of
SEER.
people still put those in the attic because they don't want to insulate the unit itself, so the condensing.
The condensing.
Don't freeze.
Can freeze.
So how do you, in the event that we put one of the high efficiencies up in the attic, what's your procedure for ensuring the condensate doesn't freeze?
We'd probably insulate the attic. We'd insulate up to the roof.
And and probably put a small unit heater to keep it above like 40 degrees.
Yeah. I mean, if we're gonna put mechanical equipment in the attic, I would always advocate that you insulate above.
Above.
It's in the air-conditioned space. Or I shouldn't say air-conditioned, the conditioned space.
Yeah. And what kind of insulation do you guys typically recommend? Because that's going to be a truss system. I would imagine.
Well, unfortunately, if we're talking about this much equipment up there, we may not even be able to use a truss because you need to design into it enough space for all this stuff and access. So we may end up having to go with more of a beam framed system. And then we would be insulating above the roof with maybe some supplemental spray foam or something underneath. So the total would be somewhere around, I don't know, whatever it is, 49 now, I think, for a roof system, R49.
On the residential side, I think the commercial side is commercial.
I think they changed it in 2015.
They did, but there's exceptions.
In the energy code. So whatever the energy code says we have to meet, we will definitely be meeting that. Whether we go a little bit above it or not is something else. Ultimately, it's more about air sealing it than it is getting maximum insulation up there. But to be honest with you, it's actually easier to do that and build the building than it is to try and do insulation at the floor level, at the attic truss floor level, because of all the penetrations and trying to get a vapor barrier to work correctly from the outside wall and then back in through the roof. It's it's much more difficult to do that. It's easier for the builder actually to build it right up and over.
In your experience, Jeff, given that we would, if we go with, the base code system, we would have to potentially modify or not even use the truss system, would the savings of a baseline system over one of the other options be outweighed by the construction cost of accommodating that?
I don't know. It's really hard to say at this point.
The remanufactured trusses are probably the most economical way to roof buildings. But it's hard to know at this point without having a design.
Yeah. What's your gut tell you if you had to?
My gut feeling is it may not add as much as going from the baseline to option one. It's $23,000. It may not be $23,000 worth of materials because ultimately it's going to go together roughly in the same time frame. It's not that big a building.
But it is going to have a material cost impact.
It may have an imperial because you may be having to switch to something like steel for part of the roof.
Yeah.
Question for you, on option 2, does that have anything in the attic?
Yes.
Yes,
That's a high
all the
efficiency
systems
burner?
will have an air handler
Yeah,
to
so-
move the ventilation air or the air conditioned air throughout the building,
Okay.
depending on which system and that. So we'll have a unit with a fan in it.
Yeah,
And ductwork.
So option 2 would just have a unit with a fan, it would have a coil for the hot water and a coil for
right.
cooling. So there wouldn't be burners or things like that.
So you're not going to be looking at, is that going to make a difference in the trusses versus non-trusses, the insulation?
Still have the same-
In other words, if you went with a higher,
Unit
if you went
doing
with, a-
ventilation, I'm assuming it would be one unit doing ventilation air for the whole building. And
We have done 4 just to match each unit with a little type of, they're just like cartridge
yeah,
type energy recovery units, but
the ERVs.
the
But
ERVs,
on the ventilation side, you'd have an air handler, I'm assuming.
all these would be doing
Okay, great.
these
So
would
that's perfect. So-
all be doing their own.
Depending on how big the ERVs are and the ductwork, we could potentially string that through trusses.
Yep.
As long as you can get a person to walk through the truss for maintenance and access, which I think we can design into a sort of stock, like a light truss, we can do it.
yeah,
System 3, every other system will require a bigger air handler, and the more air handlers and machinery we're putting up there, the less and less stock trusses we can use until you get to the baseline. And basically, System 1 and the baseline are pretty much the same in its impact to this attic. And at that point, we're in the whole attic, like it's occupied space. So it's all opened up.
but system 2 is not.
System 2 would have ERVs and
The
a,
air handling
Yeah.
units, the thing is you don't have to pipe each one of these furnaces, so you don't have flues and air intakes on each one of them
But how
to
many
go
would
out
you
with the
have
hot
in
water.
the attic?
Still basically the same.
We still kept it the same as the base,
so
you
you still
know,
have 4
4, 5, I think 5.
of those units. So
Five.
yeah, so System 2 is still in the realm of not having trusses.
Right.
We'd
Right.
have a beam, we'd have to open up the space. So System 3 is really the advantage there, is that we could most likely keep the regular truss, cheaper wood frame truss construction.
Okay, I guess where I'm going is that and correct me if I'm wrong, if with system 2, if there's only air handlers up in the attic, does that reduce our construction costs? And as you say, insulating up in the roof, like
Well, we'd still
like
insulate
option
with
3.
Option 2, because correct me if I'm wrong, we're going to have condensate pumps on
2
those
would
two,
certainly be
yeah.
the same.
So we're in that same,
I see option 3 is maybe just an area.
I think architecturally, the
That
cost breakdown between System 3 and all the others. System 3 is probably cheaper from the architectural side than the other systems, and all the other systems are basically the same cost, they're more. more money spent for those on the architectural side.
That's
So
probably
like-
not $60,000.
No,
Probably not 60.
Probably in the order of around 20-ish, so like a third of the 60,000 is,
You think it would roughly be, like on the baseline system, it would roughly be a single point of access through the
Yes.
ceiling?
Yep.
Okay. What's their limitations? Does it need to be a
Well.
pull down or
A roof hatch and
Yeah, pull downstairs.
Okay.
something.
basically it's gonna be able to get the equipment back down.
Right.
I don't know, sometimes you do that through a louver.
Yeah, you do
Yeah.
a louver
Oh, yeah.
on the side,
Just
at the
go
gable
out to the side.
louver.
Yeah, that's how you get them in and out.
Yeah, if you have to replace,
Cut a hole.
Like what you want to bring through there is you know, any filters or belts.
Yeah,
That would go through the hatch.
So if construction costs are $20,000 more for 1 and 2 and base, then the real difference is 40,000, not 60,000.
Approximately.
So then we just have to decide if that's,
I mean, we could, theoretically, with an 80% boiler, we could get away with not insulating the attic and making it conditioned space. We could still insulate the flat.
To be honest with you, I'm not sure there's going to be a whole lot of difference between insulating at the top of the roof and versus insulating at the attic floor. And like I said, the complications of insulating at the attic floor probably add enough cost to outweigh the minimal cost of going up and over
Up
the
and
top of the
over.
building.
And it's much more usable space, even if it's only storage.
And the up and
You know,
over is
there's
gonna
some,
have
potentially
some
some other.
ice dam prevention in
Yes.
it. And since we're not doing gutters too, that's
Yeah.
another thought that, so.
I guess the other piece that at least owners should enter into our thinking, I mean, if we're, to some extent, if we're supposed to be a green community, and and we go with the baseline, I mean, that is like 80% efficiency is horrible. You know, and your gas costs are going to go back up at some point, you know.
Yeah, the other thing, these don't include any rebates, so there would be some, you know, rebates that would also, you know, it's probably not more than, you know, a couple $1,000s, but, for a building of this size, but those haven't been factored into any of the paybacks either.
So they keep changing.
Did you do any carbon analysis or anything like that?
No, we did not, but,
If you had to guess which one is
I would,
is the greenest?
I'd say 3,
most
2,
sustainable?
1
Yeah, all right,
baseline.
that's what I figured.
Yeah.
Just going on the efficiency
Yeah,
side.
just going on efficiency and
Burns less.
overall fuel usage.
Exactly.
And the dollar per square foot operating cost, that's a good indicator. We've seen that too, more and more. It's kind of contrary to, say, 5 years ago, you never think of using electric for heating. We've seen more and more that happening because of reduced carbon output, and then being offset by site-generated PV, you know, or municipal generated electricity that offsets that, to try to get to like as close as net zero as you can.
It's also not traditional electric heat. It's not a resistance
Right,
system.
right,
It's
right.
basically an air conditioner in reverse.
Right. And even, it's, again, not, even at a 0-degree day, there's energy in that air.
Right.
You know, that.
One other thing that's always interested me, what about geothermal?
More expensive.
Very,
Yeah, the
Quite a
install
bit.
cost is,
And it's also you're also rolling the dice as to what's underground and how deep you have to go. And
So for,
the first hole you drill is your test hole, but you're spending an awful lot of money to drill that test hole, and you may be wrong.
probably about $100,000. If it's, you know, 15 tons, you get about 3 tons per well. They're about 20,000 each. So 5 wells at 20,000, that gets you your well and your piping, and actually it's probably another 10 or 15 of pumps and accessories, so.
And that doesn't even include air handlers and anything?
Well,
inside?
no, that's on top of these
Yeah.
costs.
These costs, yeah,
It's
so
about
it's about
115, 120 on top of these systems, and you could pair it to a VRF system
Or two, potentially.
or two, the hydro air systems.
Yeah, you're really trying to get the
Instead,
payback.
you'd go with a heat pump
That's
instead of.
what you're trying to get, is the payback, and on this size of a building, you're never gonna get that
Yeah.
payback.
Yeah, as long as gas prices are relatively low, the paybacks on the systems are far out.
Has there been any discussion in town about solar on town-owned properties?
No.
No? I should agree.
Discussion in town on solar on town-owned properties.
There has been no discussion that I know of.
One of the, we had a hearing on the ZBA. A resident wants to put in a solar tracker. And those are the things that come on when the sun comes up and it tracks the sun across the sky and then goes to sleep and waits until the morning. And the resident has told us that it's a 4-year payback on a $41,000 system,
But that's
including the rebates.
That's the big key,
Yeah.
is the town doesn't qualify for those rebates. And that's about
30%.
30% plus there's
The
additional
extras.
ones. So it's probably more of 40 to 50% rebate. So that doubles your payback instantly, at least. That's why I think Jeff has designed a solar-ready roof, but solar options for municipal buildings are pretty limited.
Interesting when they want us to be a green community.
But the town would get the rebates on purchasing the equipment.
The mechanical equipment, yes.
So you'd like a decision,
Well, I mean, if you can muster up the votes to make a decision, I know Don would really appreciate that. Other than, if we don't get a decision, there's not a lot they can do on the design end of things until you do make a decision. So if you aren't able to make a decision tonight, it would be very helpful if you were able to make a decision in the next week or so, just so that we can keep things moving, because, we are trying to get to a cost estimate, and in order to do that, we need a pretty well-developed mechanical design.
So to Colleen's point, when she did the math and said there's a $40,000, the 60 less the 20, there's a $40,000 difference. Is that?
Yeah, we're making a little bit of a guess
From
on how much the
baseline to option
architectural
3.
cost.
Yes.
Would
I mean, that would be the
yeah.
net about.
I mean, from my perspective, it's tricky because the more units you have, the more opportunity for failure you have. But at a certain point, the cost of those units changes the math. So the cost of a larger air handler and furnace, what did you carry for the option one? Like $9,000, $6,000, $8,000 a unit at 5 units versus $3,000 for 15. From a maintenance perspective as well, I would lean more towards option 2 and 3, and just based on the numbers and the payback, that kind of pushes me towards 3, but that's just my opinion.
Well, 2's more expensive than 3.
Yeah.
If you factor in, again, the back of envelope estimate of 20,000 in construction costs not to use the trusses, I mean, 2's out. It leaves you with baseline 1 and 3, really.
Yeah, I mean, I've personally done a lot of the mini splits and non-ducted components, and they work fantastic. I just put one in a ski house in Vermont. The design
Right.
temperature up there was -10.
Yeah, we're looking at, we're working together on a feasibility study in Scarborough, Maine, and we heard firsthand from the town, like that's their,
Maine is almost entirely going to this type of system,
this type of system.
VRFs.
Well,
Leave it this way, I don't think a week or 2 weeks is going to make it any easier
Yeah.
to make.
No.
Well, is it worth doing a quick exercise to see at least, I mean, P3's in favor of baseline, but is it worth going through an exercise to see if that's actually going to impact the truss design?
We could talk to the engineer and they could give us some indication as to what the two different systems are, and then we could try and put some numbers to it. You know, if it comes back and they say, you know what, it's really only a $5,000 ad,
Yeah.
how much does that change your, I mean, maybe we could play that out here, you know?
Yeah.
Do two scenarios. If it doesn't really add anything, or it's a $5,000 ad, does that change your mind versus a $20,000?
And there's probably, you know, we kind of went back and forth, there's probably somewhere in the order of $15,000 or $20,000 of VE, you know, that we could think of on option 3 with, like, you know, if, like I said, if you go to wireless thermostats, you know, 15 units at,
Is,
rough number, $1,000 to wire from there to there, go wireless, that's $15,000 less.
is there,
And it does nothing in terms of energy efficiency.
Right,
You know, it might be, you have to change a battery,
Right.
right.
you know.
is there an opportunity to group some of these systems together so we don't have quite so many zones? Like if we have a fair
On
number-
option 2,
On option 3.
on option 3.
So if we have, you know, a fair amount of
You just
rooms.
went from the-
Different heads, yeah.
We have a fair amount of rooms that are similar location in terms of, you know, glazing to the outside and exposure, that the temperature difference between the 2 or 3 is not going to be that much, considering we have a low occupancy.
You have to put a head in each.
We have to
Yeah.
put a head in each one.
That's where the
Yeah.
15 comes from.
Yeah, but I'm sure in terms of, do we need to have individual zone control for all?
It kind of already
It's already
comes
built in,
with
that's
that.
what I
It's
was
already
just
built
curious.
in with that. I say that, you know, like I said, I think you could get $15,000 just by going to wireless thermostats on that. And if you said it's 40 and minus 15,
Now you're at 25.
now you're
So-
25.
So I'll throw this out there. At 60 grand, it's kind of hard to swallow,
Yeah.
all right? At least from my perspective, I think I'm in favor of the most efficient because of what it would be as a benefit long-term. I think it also sets an example for, you know, what we're asking the community to do by adopting a green community and all that. If you start taking that number down from 60, it starts sounding really appealing. So if it is going to impact and not do the trusses, and that's going to have a meaningful impact on that number, then I'm leaning towards 3 and not just doing the baseline. I think if there's ways to trim the number so we get it down even further, then to me it becomes, I mean, if we get down to $20,000, $25,000 difference, it seems, I start scratching my head why we wouldn't do that, because that also then increases your, to some extent, you know, you'll increase your payback a little bit. Because if you take, not for the construction cost piece, because that's still there, but if you're able to pull some stuff off, like if it is wireless thermostats that do that, I mean, now you're still getting better again. And the units aren't such a number that if you have to replace a unit because it's fried, it still has to be budgeted properly so that that money is there and doesn't get eaten up every year and goes back so that it can be there for the next time.
Yeah.
But that's more doable than that. And to your point, it's not a $10,000 or $12,000 unit that's gone down that we have to wait 3 weeks to get. That's going to have a huge impact because half the station's out.
Now, refresh my memory. If one of these units go down, it doesn't, the whole police station doesn't lose
It's not like the old.
their heat.
Just that room.
Okay, that room or that area, that space.
Whereas the other options, if a unit went down, you lose 4 or 5 different spaces, or the day room, like, you know, how we essentially zoned it out, so I think like day room would have 1, locker room would have 1, the offices would have 1, so you would lose that block. Whereas if option 3, you would just lose 1 office instead of all the offices.
Yeah.
Or instead of, you'd lose, you know, the men's locker instead of the men's and women's locker.
So you'd be looking at, I mean, the things that come to my mind would be booking area and holding cells, which aren't used that frequently. To me, that would make a zone
Yeah, it is, it's all,
And, you know, we can't hold them overnight anyway,
Right.
so it would only be until
Few hours.
sundown, and then they go down to the county.
yes. So it's kind of been designed like that for all the options. Like, the holding was one, locker room's one, day room one, office the other. It's just option 3 within that block has additional units, so it has additional controls, and then the benefit of it is you might lose one unit, you only lose in an office and not the whole office area.
Or one cell and not the other.
Yeah, we won't put them in the cell, we'll probably do fan
Yeah,
coil
yes.
version on that one, little,
So can you, in a week, find out what the construction differences
Yes,
would be?
and I was just thinking, because we still have to talk to Chris,
Yep.
and I think we should probably make a financial decision until we hear from Chris, what he has to say to us. But I'm foreshadowing the next discussion. But it probably is prudent to get back to you about the structural implications, because it may make a choice easier or harder, depending on what we come
Yeah.
back with, about which system you want to go with. I don't know if you have a mechanism, maybe you just call a quick meeting to take a vote or give us direction, but once we are able to get back to you, which may be, potentially by the end of the week.
Yeah, we just schedule a regular meeting for next
Just letting
week.
us know would be helpful.
And is there any way to find out what the rebates would be? I mean, if it's $1,000, that's nice. If it turns out to be $5,000, well, that's the bigger impact.
I think you're probably maxing out at around 5,000. You're probably somewhere
I think it's
between.
all, the problem is that they may not
probably,
be able
I'd
to.
say probably
Right,
about
they change.
I think
2,500
it's-
for the HVAC. Lighting might get you, a little bit more.
I think it's more important just to feel comfortable that if we tweaked some things there, like the thermostats, that would be real savings. I think that would help to.
So we'll
Make a
do
decision.
two things. We'll look at the structure, and then, Dom and Zell and I will have a conversation about what other things regarding option 3 are on the table for the discussion, and what can that do to move the price, cost estimate, so that coming at it from 2 different angles, maybe it helps. And then we'll get back to you with that information.
Okay.
Good, thank you.
Great. All right, Chris, you're up.
Okay.
Police station?
Actually, didn't vote on that one.
Nice meeting you all of you, thank you for your time.
Thank you.
Septic is what I want to discuss.
Yes,
think that's
I got it.
And this is not the end all, this is just to start the conversation, I think. So it's just to kind of review, I had copies here that also have the as-built on the back. Oh, okay. So there's a two-sided letter of it.
Sorry.
Here's what it is, as-built. Okay. Sorry, Jeff.
Give me that mic.
Does everybody have a copy of the letter we drafted on the
That's it,
yesterday?
to everybody, I don't know if everybody's read it.
So
Some of the sketches, we can pass those down.
My
we
notes
had,
my notes on page 2.
we have done some research and hoping we can start a discussion with you, and maybe you have some more insight on the existing systems as well. So essentially, you can also pass, this is just a graphic. We had gone down to the Board of Health, opened up the file, and looked at what's on record at the Board of Health. So the first page of the letter is the documented information that's in the file. Talks about the police station, the town hall, and the fire station. That was the original design of the septic system. So these numbers and these flows were off of the permit application that was done. So at the time, the police station had a design daily flow of 242 gallons per day. The town hall was 738 gallons per day. And then the fire station was 130 gallons per day. So the total design flow was 1,110 gallons per day. Now, there was extra capacity that was designed into the system. The leaching field is bigger than what that design flow is for, and that's on the permit application as well. So the third paragraph on this first page discusses how the design flow was 1110, but the actual field is designed for 1909 gallons per day. So then we started looking further into the file, and also the as-built plan that's part of there was an inspection on the existing system. So apparently there was 2 additional buildings that were tied to this system, which we believe, according to those documents.
Okay, let me stop you there.
Yep.
I had a discussion with the highway surveyor today.
Okay.
The highway barn was in the process of being designed and constructed at that time. This system was designed with the highway barn in mind.
The original system.
The original system and the repair. So the barn was built in, I don't know, late 90s.
Right.
Might have been 1990. And I'm going to jump ahead to some of your other assumptions here. There are no floor drains in the highway barn.
That's good.
It drains out.
Good for us.
There is no black water which goes into the townhouse system. It has its own tank, which is pumped.
Okay.
So the only thing you have is one toilet, one urinal, you have 2 wash basins, and even the eye wash system drains on the floor. So you have 1 bathroom, that's it.
And it goes to a tight tank.
No,
It-
that's,
Or,
the one bathroom goes.
Your
into the
gray
system.
water goes into the SAS here. It goes into the first tank.
yeah, the as-built shows it going into a tank, and then actually bypassing the siphon chamber, so I think that must go by gravity to the leaching field.
It does, but it can't go as a trickle. It was designed that way, so, anyway.
Yeah.
So there is only 1 toilet, 1 urinal
In the field.
in the town barn.
Mm-hmm.
That's, and 2 wash basins. And that's it. So, and it has its own tight tank for black water, which is pumped on a regular basis. So the black water does not go into, so it's only your basins. That's it. So
Okay.
that's not adding much capacity.
I don't think the barn is that, yeah, on the second page, basically what we did is, the highway barn and what we believe is the fire department living quarters is part of the system. There's no documentation on daily design flow in the folders for those 2 buildings. So these were just estimates on what we would typically do for a Title V system. So we had the highway barn at 514 gallons per day, but based on that discussion, there's probably little to no water that goes to the
14
septic system.
gallons a day,
So
maybe.
we could just eliminate that flow or have a small portion of that flow. For the fire department living quarters, you know, typically you could say if there's 3 bedrooms in there, you would design it like a residential house, 110 gallons per day. So we're estimating that potentially adds 330 gallons per day to the system.
There's only 2 EMT/paramedics on duty at any given time. So you're talking 2 bedrooms over there that are in use 24 hours a day, 12-hour shifts. And I believe there is a bathroom over in the fire department. There's no sleeping quarters or anything over there.
Right, and the fire department was, you know, that was as part of the original document, as the original permit, so that was covered there. So, I mean, if it's 2 bedrooms at 110, you know, that reduces some more of the flow, so that,
I think that still puts us over with the estimated flow of the new police station.
yeah, so if we're using the same rationale as the original permit that was done for this building, it would be 75 gallons per day per 1,000 square feet for office space, and 200 gallons per day per cell bed. That's a high number. That's in Title V, that's taken from correctional facilities. So,
Is there a mechanism?
in terms of,
That we put in.
so even if we take away, we're saying the police station is leaving this building. So there's some flow that comes off of that original design. That was 242 gallons per day. I guess we need to know, is that space just going to be used for storage now, or is Town Hall going to be moving some office into that space? That is a flow consideration we need to,
Space we use for storage.
we need to get our hands around, because that can adjust the flow as well.
I think most likely it ends up, I don't think you end up bringing, we don't have anyone else to bring in.
Mhm.
So it means that you spread out space more, so it's not like we have people off-site in another building that would be brought in.
Right.
It would be the contents of this building being used
Spread
a
out.
little more broadly.
Yeah.
So basically, we would probably just drop the 200 gallon per day, one cell in the police department's new role as extra office space goes down to 42 gallons.
Yeah, okay.
So we gain 200.
All right, so I'm,
Plus 200 there.
Yeah.
yeah, so then, I was doing a little math as we were waiting as well. So that, if we were to say that 200 goes away, maybe the fire quarters is only 220 as opposed to 330. If there's only 2 people really in that building, that would then put us around 1998. So that, puts us underneath the 200 gallon per day flow, which is another key flow in terms of septic systems, but it brings us closer to that 1909.
Is there any,
Now-
sorry, go ahead.
I mean, in terms of actual police stations, there's nothing in Title V that defines what a police station is for daily flow. We have done on past police stations what they call alternative flows, where you would use water meters from readings from a similar building, or I'm not exactly sure if we have a water meter on this well in this building, but there's potential we could, through DEP, do an alternate flow to bring, a number down to that building, so.
Since our proposed police station won't house anybody overnight, is there any additional mechanism that we could use to reduce that 2 beds in the new facilities? The 400 gallon per day number?
Using 400 gallons.
I mean, that's going to, they're
Yeah,
going to.
I mean, that does seem,
Life of the building.
right, that does seem like a high number. We were just using the same rationale
No,
as
I-
part of that
it
original.
Makes sense, I understand.
I mean,
the
I think
rationale
it's-
We go to the
It
state
just doesn't.
and get a
It's a
different
discussion with the
flow.
local board of health.
Well, you've got 2 of them
Yeah,
here.
I understand that. I fully understand that. So that's what I mean. This is not an end all.
I think one of the things that we need to take into consideration with the cells is that if that building is not sprinkled, that detainees cannot remain overnight. And we presently have an agreement where they go down to Plymouth County Jail. That's where they stay. It's only a holding cell for a relatively brief period of time, and then by agreement with the sheriff, they go down there. So they cannot stay overnight, so they can't take a shower in the morning. They'll get cleaned up because they won't be here.
Right.
So, I don't know, my thoughts would be that, if you detain somebody, you might get a flush or 2 and a washing of hands in the basin, but,
I think our next option is to find a mechanism to reduce that 400 gallons a day through DEP or you guys as the Board of Health to, and that would bring us in line with our
Right.
existing capacity.
And even the office space number, Jeff, I'm not for sure, like the 52,550 is truly the office square footage, but, even that could pare down.
Yeah, my quick math is that we're at 1924,
Mhm.
and that gives us, we're like 15
Yeah,
over.
so that's 9.
Yeah.
So,
yeah, I mean, the bottom line is, we're not moving any more police officers into that building than we presently have up here.
No, but it's a space.
Yeah, I think I agree with your approach. We say that the cells are
It's the
gone, so
cells
we eliminate the
that's-
200,
cells
and then
facility.
1,000, we've got about the same amount of square footage, so that 42, whatever gallons per day, maybe if that even goes up to 43 or 44, just because you include the square footage of the cell, it does not, if that's not what's breaking the bank here.
It's the 400.
It's that 400 from the new police station.
Yeah, and yeah.
That's a lot of toilet flushes.
If that could be reduced in some way, that would be, then we'd have no question, we would be under the threshold of the system.
So do we know, is there any indication of where we start looking for relief from that criteria?
Well, like I said, there's one thing we do is an alternate flow.
Okay.
Based on, similar size stations, water readings. We have done that in the past. I don't know how many staff would be on the staff?
Here?
Yeah.
What do you consider a police station staff? Because there's the patrol officers who don't actually work out of the building, and then there's the chief, basically a secretary, records officer, and a sergeant in the building during the day. So like 3 people are actually working in the
Yeah.
building.
But even the sergeants are on patrol.
That's right.
A similar, this station is actually pretty closely matched to the Hampton police station. So I don't know if getting water readings from that facility might be, that's probably pretty accurate.
Yeah.
What we designed.
I mean, because it's, a 24-hour building,
Yeah.
really, essentially. You typically take everybody that's on, everyone on the roster. And then you're taking those daily water readings and that's how you're dividing.
But we
You're
have a
saying-
large part-time force.
Yeah.
So if you just look at the roster, I mean,
If there's a part-time-
9 full-time, and then
By roster, you're talking
Right.
about hours per day.
Right.
Shift
hours
type
So
per day.
thing.
if someone works 4 hours a day, we'll factor in all that to get equivalent full-time employee number, and then do it that
3
way.
shifts, 2 officers on.
But it's not always 2 on every shift.
It's okay.
That's but Chief Dillon would be,
Anybody that wants to volunteer,
Yeah.
it's 24 hours for the police department. We need
Yeah.
the biggest number possible. of
All
staff.
work on
Because we want the lowest rate.
Yeah.
Yeah. So yeah, it's chief, secretary, sergeant, 3 officers per shift.
Right. We could figure out how many hours.
well, not 3 officers per shift.
Well, let's
Max you have is 2, including the sergeant on patrol.
trying to help Matt.
Oh,
We're going the wrong way.
I'm sure the chief can come up with this, on Old Home Day or when there's a parade, I'm sure he has more officers on duty on those particular occasions that we can say, this is our representative.
But I think that would be one route, because you could get DEP to approve that letter, and then you would have that on file. It's just because in Title V, it's kind of difficult, because it has the correctional facility, but then it doesn't have anything
Yeah.
other to go to. So, it has the office space, so we can say that we have a certain office space, but there's nothing really that talks about those cells. I mean, there's bedrooms and boarding rooms, boarding rooms for 55 gallons per day, something like that. But
Because this is technically code classified as a resident. Is it a business
It's a
accessory?
business, so
Business accessory. There's
Mhm.
no, technically, there's no institutional use.
Nope.
Does that have any bearing on how 5? It's a completely different analysis.
Well, I mean, I don't want to put, really, it's, the authority it's a local system.
So does that have
So I
any-
don't, I don't know. It's a discussion to have with Board of Health, with all the members.
Yeah.
Because they are the authority, so, it's not a DEP level system.
I mean, it goes back to the point you made
Yeah.
about how
Everybody has to be
minimal the
comfortable.
actual use
Yeah,
is. So
and I-
could be a
and I think a question,
ruling made.
I think a question for Chief Doyle might be, how many times was a holding cell used last year, the year before, and the year before that, for the last 2 or 3 years? Maybe it's going to be 2 days a year, or for 4 hours per,
Right.
per incident. And then in my mind, that's not much impact on the usage. But I mean, Chief Doyle would,
Ultimately, doesn't
Dylan,
it
excuse
go back
me.
to the state to get sort of, you guys as Board of Health would make a decision about how you would look at it. That would have to get approved by the state, and then it could be enforced here. And that's the procedure, I'm assuming, right, Chris?
No, I mean, this is the size of this system is a local board of health.
So they can
It's
change-
not necessarily, I mean,
they
we're
can
not
change
you
their
know,
classification.
changing. I don't know if we're saying we're changing anything, I think it's just the rationale on how we come up with the number, and is Board of Health, comfortable with the way that rationale has been put forth in front of them.
Okay.
So we can go back and do a little more homework to get that number and put it in front of the board and see,
Sounds good.
if
Yeah.
everyone's comfortable. If not, then we can, if we want to go that to the state level and have a flow, alternate flow, that's another.
I think
go that route,
your
so.
first option seems like it's going to be the best route to pursue first.
Mhm.
And obviously, if it doesn't fly with Board of Health, then we'll try something else. But, I think we're very close now, so it should be.
Right.
Well, I think with
We're close now without dealing with the cells.
Right.
Yeah, exactly.
To me, that's the huge number there. It's just.
Yeah, we'll have the board look at it and the health agent.
So would it be sufficient for Chris's office to put together a new rationale and then submit that to the board?
Second Tuesday in September.
Hold on, I'll tell you.
Yeah, if it can work.
So this is not as critical as the HVAC system, right?
Unless there's the wrong answer.
Yeah.
Because, well,
Every indication
Well,
seems to be that we can make it work, so I'm not worried about it.
It's not as,
September 12th.
Board of Health doesn't meet again until September 12th.
I don't see that as an issue.
Yeah, I don't.
It's not
Yeah,
as
I mean, if we were looking at
significant as
the real possibility that we would have to expand the septic system, then we'd need to do things on fast track, because we need to know some answers. But we're so close, I don't think it's going to impact the project.
So we can assume that there's no extra cost here.
I think it's safe to say that that looks like that's going to happen.
Sound good to our OPM?
That's always a thing we like to hear. No cost.
Don't push it.
So the officers, they have to go down to the mobile station.
Right, exactly.
We could make both chiefs use the same.
Anything else?
No, that's it.
Great.
Okay, so then it looks like
Thank
we
you.
need to meet again next week.
Okay, and that would be,
We still have a few more things we want to get to on our agenda.
Yeah. Because these are just printouts of the status of the drawings as they stand right now.
For your meeting, not necessarily anything we need to go over specifically
No.
right now, but we can take a look at.
Well, what's, on the first few pages are the progress on civil drawings. And there are some questions regarding a few items that would be affecting the actual civil design.
We just read this.
Thank you.
thank you.
Thank you.
So, well, if you look at, if we could see, start with, so, we basically skip the first few sheets, and you go to C1.0. This basically outlines what the sort of the site demolition work that's involved would be. But one of the things that's come up is that the civil engineer feels that we weren't showing enough of a clearance of tree lines from the building in our original site plan. They recommend approximately 15 to 20 feet of clearing beyond the building line. And there's a reason for that. The reason is that each utility, we've got 2 utility lines, we've got an electrical duct bank coming around, which you will see if you go to the following 2.1. See 2.1, 2 sheets beyond? You'll see that right now, that two service lines, one is being the gas coming into the back of the building, and the other being the electrical conduit banks, which are below ground. And the advice is that those should be separated by a minimum of 5 to 7 feet. Plus, they should be approximately at least 7 to 10 feet away from the building. And then there should be some clearance for any vehicle that might need to get back there for some reason. And so that's how they come up with the recommendation of 15 to 20 feet. Not to mention the fact that depending on the size of the trees and size of the branch spread, that could also be a good reason to make sure that there's enough clearance behind the building. Keep that tree line away from it. Currently, what we're showing is a transformer, as you can see in the corner, it's marked by T, it's a square. What's the, I guess, the south, northwest corner. And that would be an underground line coming over from the utility pole the utility company would be wiring it, but the GC would be actually installing the trench and the conduit. And from there, it would go just underground and then enter, after the manhole, enter into the building. There are some couple of other items, which next to the garage, there would be a holding tank for the waste coming from the garage, because that has to be handled separately. And so that's something that has to be buried. And even though these are designed for traffic to be, they can be below traffic and parking areas. So that won't obstruct any future, planning for.
What are the other questions that they want to get to?
The other questions are regarding the emergency generator, which has not been cited yet on the site plan. We basically need to know whether that's going to be on a diesel power fuel system or whether that's going to be a gas-fed. So in case,
My experience is we have the gas on site.
Right.
Yeah.
You don't need to fill it, you don't need to do that.
Yeah.
So there's two considerations.
Right, there's some-
Neither chief is here, but I'm sure what they would say is, public safety concerns are that if there's an interruption to the natural gas supply of some sort of event, they would not have any backup generator. If it was a natural gas fed generator, you'd get nothing if there was an interruption. So having a portable fuel like diesel allows you to have a truck come and fill the generator, and that's seen as more reliable in an emergency scenario. On the other hand, a diesel generator is generally a little bit more expensive, it's a little bit more noisy, and it has the tank, it has the fuel on site, with a big tank sitting under a bladder underneath.
And more maintenance.
And there's maintenance, more maintenance associated. So there's pros and cons, but typically a public safety view is that diesel is a better source. There is a possibility or a thing called a dual source generator, dual fuel generator, but they're going to be more money, and I don't think it's appropriate here. So I don't think we should consider that. But
Propane's too expensive too, right?
Propane's essentially the same thing as natural gas, but it doesn't have the same power as natural gas does. Propane's a less, I don't know what you call it, less powerful fuel. So you need a bigger generator, and you need more propane tank storage for that to do the work.
But there's no mandate saying we have to do diesel. It's just suggested.
It is what is written in the public safety or best practices, but there's nothing telling you have to have one or the other.
Is this something that we should consult the chief?
I think so.
Probably something that the chief should weigh in on. It's going to be his building long-term. It's probably appropriate
Or short term, every time.
Yeah,
participate in
I
the
think
decision.
So
As a
bringing a
short-term,
diesel
we'll be
tank
retiring.
in brings in a whole new consideration of other problems and expense, I presume, leakage.
Well, the way these things are designed, they're a sort of off-the-shelf item. It has all the safety controls as the package that you get. So when you buy a diesel generator, you don't have to do anything else. You just put a concrete pad down and set the thing in place.
It comes with its own
Don't they have,
500-gallon or something tank that it actually sits over. I mean, depending on the size, one thing is that the generator hasn't been sized yet for the actual load. So that will depend on its physical size and output. So, but generally speaking, they are off-the-shelf items.
In terms of the
You don't need a
security
separate
issues,
tank.
don't you have to run them every week or 2
There's,
weeks?
but you'd have to run either
Test.
generator.
Either side, they test
It's
every
a
week.
weekly test,
Yeah.
about a half an
Test.
hour
Yeah.
runs it.
I mean, I have a whole house generator powered by propane, and they automatically start once a week, exercise themselves, shut down, and go back to sleep for the next 7 days. Yeah.
That's right. That's exactly how it operates.
You know, and mine is small, it's only 15,000 kilowatts, but you go up over that and you need a liquid-cooled system, you know, which is fine. And you can get those up to any amount of kilowatts you want.
Sure.
Very large.
Yeah, basically, we're just building a little diesel
Yeah.
engine, you know, and behind the building. And it's not complicated at all. There really isn't too many safety concerns with these things. You know, I haven't actually heard of one failing in a long time. We did have one fail, which is the worst one to fail, was on the roof of a building. But that was during construction, so there's a different scenario there. But they're generally pretty reliable.
Yeah, I mean, you need a tune-up once a year,
Yeah.
and that's it.
So you said the diesel unit is more expensive by
Slightly. It's not a big concern.
$2,000 or by
Yeah.
$20,000?
Yeah, it's not a big concern.
Okay. Okay, the chief is on vacation this week. I assume he'll be here next week.
It's that, again, that's not a decision we need an immediate answer on. It would be nice to
That's
have
something-
whenever the chief gets back, let us know.
Yeah, well, you need the specs on the amount of the electrical
We have to
load.
do the load
Yes, we have,
calculations.
so that's why it hasn't been sized yet.
Is there any, speaking of the generator, is there any desire to have an acoustic enclosure for this generator? You can buy them sort of off-the-shelf, regular enclosure. It's going to be relatively noisy, but then you can buy special jackets with
They're
mufflers
insulated with mufflers.
that have extra insulation, so it's quieter. It's not
Where are
noiseless,
you thinking of putting
but
it?
it's quieter. More than likely, it's going to be near the garage end of the building.
Back. Yeah.
Furthest away from it.
And they sell these neat little foam earplugs that you put in like this.
How much of a
Because they plant a few
I don't know.
pine trees around.
Also, the other consideration is you're pretty far removed from any residential
Yeah,
area
it is
here, so
blasting into the woods
I
down
don't
the
know if how
DPW.
much concern.
They're not that noisy anyway.
So our perspective going into this is that you did not require
Yeah, I don't,
extra
Right.
noise
as long as it's
protection.
going over to that end.
Yeah.
And when you put it, I mean, if we were putting it on the other corner, there's some
Yeah.
people who live right across the
By the
street, but
library?
you're pretty far distant,
Cheap,
you're up higher.
that's way over.
Yeah. Yeah.
Also, if you don't have power, you're already inconvenienced. A little noise
That's right.
is probably not a big deal.
Just reminds you the police department is working.
Those are the critical ones.
The only other curiosity is if we were to plan for utilities for a future fire station. We probably need to know relatively soon whether we should be planning for this. And as our engineers and Del have discussed it, it's very difficult for us to speculate where or what this future thing might be. So in terms of bringing utilities onto the site, it's hard for us to, so maybe some discussion about that would be helpful.
But, we don't know how big a building it would be, we don't know
anything.
where specifically it would go. We're bringing gas in, and we should be bringing as big a gas line in and over here as possible, because then it's yet closer to.
Well, that's the question, right? So, we can build a gas line that's big enough for our building, and for incrementally, not too much more money, we can build a gas line that's bigger than we need. But we have to speculate as to how big a gas line we need for a future fire station of some size. And is it appropriate to just bring that gas line to where we need it for the police station? Because we don't really know where the fire station is going to be.
Well, I think the issue is get it across the street and onto the property. It seems like we should be doing that, and then if you step it down and then go in, fine, but then it's here.
Right.
And ideally, if it's coming in, you wouldn't want it in the front corner where you're gonna dig that back up again to add another,
Lateral.
So if you bring it in, I guess the question is what would be an incremental cost for, I don't know.
Well, see, what you're paying for is
Bring
the
it in
labor to
toward
dig the
T on right
trench
there.
and to form the concrete
Yeah,
duct bank.
be done
You're
with it.
paying incrementally more for a slightly bigger
Well, you
iron
can put a
pipe.
door T right there.
That's the difference.
It's almost like.
More material.
Take-
So
take
put it
the
out
numbers
here, and then you
see
could
if
run it at a fuse,
Well,
because it's gonna
I'll
be,
just have the engineers run the calculation.
somewhere up in here.
That has been discussed for this future, and it would never be probably bigger than that.
Right, yeah, because just for long-term, regardless of what we do with this property back here, whether it's a fire station or some other building, you're gonna need that gas line again, so if you're digging in the back here to tie in and then run it further back, then that makes sense.
Well, and there was also a side discussion of getting the gas down to the highway barn. So I think as big as we can go would be what we'd want to do.
You'd want to run it down the hill rather than, does it not continue
It doesn't.
in the road?
no.
Which is why it's not gas conductor. So they would.
So getting it closer to them would be helpful as well, which is.
Exactly.
Yeah,
Which is that back corner there, so, yeah.
Okay.
yeah, so they could dig up the hill towards that connection.
Right, so it would need to be sized for the highway barn as well as that number we have for a potential fire station that we haven't even decided, and then should be big enough because I don't think it should have been smaller, so.
But it's fair to say, the fire station's been sort of a political football and pretty hot ball along the way, which is probably why there's some smirks around the room. But we don't know, it could be.
There's gonna be something, we bought
There
the
is,
land to
exactly.
build something,
Right.
and you've gotta come under the road with this thing, we wanna do that once.
Yeah.
And we wanna dig,
Gas lines there.
and if we do all this and we put, we get this all done and we're 6-7 years down and we get that entrance in and all that, great, and then we have to go dig back up over, no, we wanna
Right,
get it all the way.
and the point
Yeah.
being that it could be a fire station, it could be senior housing, it could be a
So-
new townhouse, and if it's incremental, we absolutely want to have that. Or, speaking for the Board of Selectmen, I'm not a member of this board, but this committee, we definitely want the flexibility to build something there in the
In the
future.
same vein, putting some extra conduit in the electrical duct bank for power, future feed to a future fire station of wherever, to a handhold box that could be, connected to in the future.
I'm a big fan of putting in extra conduit
That can really-
everywhere.
Yeah.
Because
I-
we can't go beyond,
We could put it in to a point here.
Yeah,
We're
we can
getting
bring it in,
electric,
but
we're getting
before
electric
the-
right off the pole.
Right, we do have to bring it in to the site, but before the transformer, we would just stop it.
Just stop it at a handhold. Yeah. And then they can pick it up whenever, wherever the fire station is, they can pick it up from that box and run it.
But it's
Where it
across,
goes.
it's already across the new drive,
Yeah.
assuming
Yeah.
you put that in.
Well, my big thing, yeah, exactly, is that we've got it encased, it's down there in an accessible location, it's out of the way, so in the future you don't have to
Yeah.
mess around with shutting the police station
Absolutely.
down to do it. Okay, good. Next.
I think, no, I think those are the main questions that we have. The only other, there is one other question related, this is related to the emergency generator, because we hadn't shown it yet, but assuming that it does go in that back corner, behind the garage, we may need to extend that, the paved section of the parking lot to that point.
Or the driveway.
Or the driveway. Somehow, they may have to be a little more paving to get, because part of the logic is you have to get a vehicle, a truck, up to the transformer in case it ever has to be replaced. So there would have to be some sort of a paved surface.
I think we were talking about initially maybe bringing pavement along the back side of the garage. Along
Yeah,
the
but-
side to the
Yeah,
back. That's not
but
in
we
this
sort of
budget.
been limiting,
Yeah.
we're trying to limit that, but you may be, so in other words, we may just extend it here. So this whole additional parking lot, future may just shift back.
May
some.
just take this line and do that.
Yeah.
Yeah.
And it's just like a double
So
line
just a
driveway.
little more paving that we would have to have for access to that
Yeah, I mean,
emergency
that,
generator.
that cost is gonna be
Is not.
nothing, because we're paying for the mobilization to get
Yeah.
everybody out there to pave it
Yeah.
and buy a ton of
Yeah,
pavement.
it's not significant.
A
It's
small
not-
chunk is not a big deal.
But it would be a little change to the site plan, that's all. That's why I mentioned it. I think those are the main points I'm going to say. And it was, one of our concerns, of course, is getting the borings done as soon as possible, because our structural engineer will need to see the analysis so that he knows what the carrying capacities would be.
Did you guys already discuss that?
Yeah, can we, can he tell us where he wants to do them? We're assuming the building corners?
That's what we,
And then
the
the slides.
last
One in the
meeting, that's what we
middle,
said
maybe.
to Dan,
Yeah.
you weren't here at that, but we
Yeah.
told Dan, assume all four corners and one in the center.
Yeah.
Okay.
Yeah.
Typical.
Did you've already talked to him, I guess, yeah, did he have a schedule?
He should have it all done in a couple of weeks,
Great.
analysis, so.
Awesome.
Okay.
So I have a question about the 5,000 gallon garage waste holding tank. What waste are we putting in that?
It's really for any spill that might happen in the
It's
garage.
required, garages
required.
can't go into
Okay.
the septic field.
And the size of that is driven by the square footage of the.
Yeah, and then
Right.
basically, you're not really paying much based upon, it's the same conversation we've been having. Once you put a tank in of whatever size, to go from 3,000, 4,000, 5,000 is really minimal. So,
No precast.
It's a requirement for us to
Okay.
be there. Because you've got a vehicle storage facility, that's it.
So
You
with,
could have gasoline spill, you could have oil spill, you can't contaminate the system, because you're gonna have a drain in the garage.
Okay.
So Chief shouldn't wash his car in the garage.
no, you can wash it all day long now, as long as he pumps it out.
That's the thing. That's the expensive part.
Yeah, well,
Well, is that it for our
I
agenda?
think that's, I mean, for now, those are the major questions.
So you'll do what you need to do on the HVAC?
Yeah, we'll get you answers on the costs of things as soon as we can, and we await your decision.
And everyone is available to meet next week?
I will not be here.
Okay. Okay.
Next Wednesday, 6 o'clock?
Next Wednesday, 6 o'clock. You or Dan will be available?
Yeah, I think that's what it is.
My birthday.
It's our goals to try to start doing a cost estimate as soon as the HVAC and structural design is to a point that we're ready.
Yeah.
And the goal being, originally in a couple of weeks, but it sounds like we're up to push that off just a little bit so that there's time after you make a decision for them to actually do the work. So hopefully by, the end of September, we should be in progress with a cost estimate. Sometime early October, we should be able to provide that to the committee, so we get our feedback on the costs, building costs.
So what we didn't really discuss, at last meeting, we discussed the heck out of the location. We got the drawing, I forwarded it. We didn't, I guess, vote on approving this design. Are we all in line with this?
Yeah, the location.
So let's just have a motion on a vote that,
I make a motion, we approve the design change.
With potential amendments for the side, because you said that we're, so with understanding that.
Yeah, that could change.
okay,
Unseconded.
all in favor?
Aye.
Opposed? Okay. That's wrong.
And I see you got the tucking in right around the septic tank.
Yeah, that was the goal, you know, fit our.
I saw that, I started, I got a smile on me with that. Like, oh, look at that. Squeeze.
All right, then we're all set. Good, thank you for watching. Good night.
Thank you.
Thank you all.
Oh, yeah. Make a motion, we adjourn?
Motion to adjourn, please.
Second?
All in favor?
Aye.
Aye.
Opposed?